Another example for this section, problem 17. Here we have this incline and this girl is rolling this ball upward with some initial velocity. Initial velocity is 4 meters per second. And because of this incline, and because of the gravitational force, the acceleration of this ball is gonna be in this direction, downward, and it's gonna be equal to 0.25 g. Well, let me write it like this. 0.25 g is gonna be the acceleration of the ball downward. And we have a bunch of questions here. If the initial velocity is 4 meters per second, how much this ball is gonna go upward before stopping, and how long it's gonna take to stop, and also how long it's gonna take for this ball to return to the hand of this girl, right? Like the previous problem, first we define a coordinate. I'm gonna define this S as my coordinate. So this is the positive direction of the S. And the location of this ball from the hands of this girl, we are gonna show it with S. And second part, acceleration. We need to check it to make sure it is constant or figure out it is not. Acceleration is given and it is constant. And because it is constant, I'm allowed to use any of these equations. Velocity is gonna be initial velocity plus a times t. Position is gonna be initial position plus initial velocity times t plus 1/2 of a t squared. And 2 times a times displacement is equal to velocity squared minus initial velocity squared. So I have these 3 equations here, and I need to figure out which one is going to be useful here. So to find the position, to find the displacement of this ball when it stops, which one is going to be useful? Again, you have different options, but probably the best option is the third equation, because after releasing it, when it stops, I still don't have any information about the time of this process, right? This movement. And if you check this equation, you don't need time first, and also you know the final velocity. When it stops, the velocity is gonna go to 0. And the initial velocity is given, it is 4 meters per second. So I have this, I have this, I have acceleration, and I'm trying to find the displacement, right? So, so I'm gonna use the third equation. 1, 2, 3. From the third equation, I have 2 times acceleration, which is gonna be 0.25 g downward. So it means in my coordinate, acceleration is negative. So negative 0.25 times g, so 9.81, times s, the location of the particle when it stops, minus initial s, which is 0 in my coordinate, is equal to velocity at the end when it stops, it's 0, minus initial velocity, which is given 4 squared. So in this equation, I have only one unknown, which is s, and you can simply find it. So s is going to be equal to, from this equation, it's going to be 3.26 meter. So the ball is going to move 3.26 meter upward to stop. Now, after finding s, now the other question is how long it's going to take for this particle to stop. Again, you have different options. Because I know what is s, I can put in the second equation, and I have S0, V0, A, so I can find t from it. That's one option. But probably the simpler option is using the first equation. I know the velocity at the end. When it stops, the velocity is 0. I know the initial velocity, I know the acceleration, so I can find the time, right? So let's use the first equation. From the first equation, I have velocity at the end, which is 0, is gonna be equal to initial velocity is 4, it's given, plus acceleration, which is negative 0.25 times 9.81 and times t. So from here we can find the time. Time is going to be equal to 1.631 seconds. So this is how long it's going to take for this ball to go upward and stop. And the last part of the question is how long it's going to take for the ball to go up, stop, and come down and get to the hand of this girl. So of course, when it goes up and when it comes down, we have a symmetry here, right? The time it takes for the ball to go up is going to be equal to the time of the ball when it comes down. And because of that, the required time to return is going to be 2 times 1.631. So it's going to be 3.26 seconds. So it's going to take 3.26 seconds for the ball to start from here, go up, stop, and come down again to the initial position.